Hello everyone and welcome to today's video. This video is part of a series where we are building a microservices-based social media application with the main focus of learning the microservices pattern and how to address its main challenges. Here is an overview of what we are currently working on. The authentication service is the current implementation. We then have plans to soon start with the front-end client, Kubernetes, Kafka, and some notifications service for example, sending emails to the users. Here's a more detailed breakdown of the tasks, and if you are interested, you can pause the video and have a look at the high-level tasks that I have planned for the next upcoming videos. I will not be describing this at the beginning of every video because if you're watching the playlist, this can get quite tiring. So in the previous video, we have implemented our send sign-up verification email method in our email sender class. And this means that now we are able to call a method that in the future is going to send the email to the user once they sign up to our application. I noticed, and probably if you are familiar with the concept of the singleton, I noticed that there is an issue with our tests, right? So I want to discuss this with you here because this is going to be relevant later down the road as well during implementation. So let me run my tests, right? And they should all be passing because this is the exact time where I stopped in the last video. But what I'm going to do now here is I'm going to remove this method that I activate my email sender. And so I just removed it, and well, if I don't call this method, I think that someone who is not familiar with the intrinsics or like with the internals of the code would expect this test to fail. But let's see what happens. And as unexpected, the test still passes. And why is it so? Well, it's because we are working with one single instance of the email sender class. And this instance is being persisted, meaning its internal state is being persisted between different tests. It's the same thing as with the in-memory database that we are working. So remember that before each, so we had a method in our setup after end file that before each test, I delete everything from my in-memory database. So this cleanup is necessary to prevent instances or to prevent objects that were created in previous tests to still hang around in the database in later tests. So we have one unit test affecting the result of another unit test. And this is bad design. This is a bad practice that we don't want to have in our application. So the idea here is that we want to make this test that it should send the sign-up verification email as self-contained as possible. Here it is not self-contained because it is depending on calling either the email sender here, email sender.activate here at the previous test. And if I remove this, then this test should start to fail if I didn't activate it somewhere else. I don't think I did. Exactly. So as you can see, by removing a test, another test starts to fail. And this is really not what we want, right? So that's why I took the time to discuss this with you in this video. Let's see how we can fix this. As it turns out, it's not that complicated. I'm going to leave this statement here, the email sender.activate out of our tests because I want to identify when exactly this is going to fail. So in my setup after env file, what I would like to do is to get my instance of my email sender. Oops. Get instance, right? And here I think I need to import this. Exactly. And then I want to call the email sender.cleanup method. And you may be wondering, okay, where did you implement it? Well, I didn't, right? So it's going to start complaining. So let's go back to our email sender class and we will create another method here, more at the bottom. We could stick to alphabetical order, but I think also semantic ordering makes sense, right? So we have some, let's say we have some management methods at the top, then we have the actual sending emails, and then we have a list of private methods that can then be grouped as necessary. So the cleanup, what it needs to do is it simply needs to reset our private internal variables to their initial state, right? So here the isActive is initialized to be false whenever I create the instance first, and the email API is initialized to be undefined. So by not assigning it to any value, this means that this is undefined, right? So what I'm going to do is within my cleanup method, I will simply say this dot isActive is equal to false, and this dot email API is equal to undefined, right? So by calling this cleanup method, now my test here should start to fail, because now I start with a whole new instance or a whole new state for the test. Exactly, so now it's failing because I don't activate it, right? I think I said that it should pass, but no, it should fail. I think it's a force of habit. Anyway, so here now it's complaining that the email sender is not active. So now I have to come here and say email sender dot activate. And once I call the email sender dot activate, then my test should start to pass. Exactly. So this brief discussion is something that can save us a lot of headache in the future, specifically or especially when we are dealing with singleton classes or with objects and with packages, or for example the in-memory database. So with objects that can be persisted between individual test runs, right? Between, for example, the run here and the run here. And to be aware of this problem and to have a standardized way of dealing with it. So in our case, we have implemented the cleanup method where we reset the initial state. Maybe here it could also be the case that we'll say this dot email sender instance, and then here I need to make this method static, right? And this dot email sender instance, is equal to new email sender. This is going to basically reset the whole instance to a new email sender. Now I need to update the setup after env, because here I would call the cleanup directly in the email sender state. So here maybe the cleanup is not the best name for it. Let's name it a little bit different. So let's call it reset email sender instance, right? This makes it very clear what this method is doing. And because it's a static method, let's put it at the top as well. Then here I can call it like this, email sender dot reset email sender instance. And this should still make the tests pass, because now the email sender is a new instance with the defaults that are populated whenever an instance is created. So it's really up to your preference whether we always need to get the instance and clean up that specific instance, and that cleanup method can really grow, right? So imagine that we have not only 2 but 10 different internal variables here, private variables, and we need to reset all of them. So we need to keep track of these variables. If we remove one, then our tests may start to fail. For example, if we remove one from here, the cleanup method will start to fail. If we remove a line from the cleanup method, then it's trickier because one of the private variables is not going to be reset accordingly. So I think that from a scalability point of view, it makes more sense to have the reset email sender instance method as a static method that is going to initialize this email sender instance as a fresh new email sender. Now this method is not to be used everywhere, right? We will normally work with activate, deactivate, set email API, and these instance methods that are going to allow us to manipulate the internal state of the email sender class. But it's good to have it, and it's required for us to have this in a testing environment because we want to reset the email sender instance before each run of the test. So I think this approach where we have a static method is less error prone and it requires less maintenance over the long run. So I think we can, or I think I will stick with this method, right? Another approach which, yeah, but that doesn't solve the problem. It would be to make so I'm just thinking in my head here, it would be to make everything static, but then I lose the power of resetting the instance, right? I don't have an instance, everything is static, the state is always persisted, so I'm forced to reset state by state. So this is one benefit of using this form of the singleton pattern. So if we have some state here, we would prevent this from being made static, and we would use this singleton pattern where we ensure that at any point in time there is only one instance of our email sender, and this instance can be reset by calling the reset email sender instance method. Okay, so this was a brief discussion that I wanted to make, and I hope this added some value, and this will for sure pop up again in the future when we have tests with objects that follow this singleton pattern. Thank you very much for your time. And if you are interested in getting the updates for these videos, I think that the playlist is getting quite long, so maybe not all the videos will be available when you watch this specific video. So if you want to follow up with the course, and if you want to get notifications every time that a new video is out in this playlist, then make sure to subscribe. And I try to publish videos every day, 2 videos a day, but I'm expanding a little bit on the playlists that I have. So it may be the case that not every day there is a new video in this playlist, but it will be quite often. And then I think that we can make good progress. It doesn't need to stall the project for too long before you can come back to it. So until the next video, and thank you for your time. Bye bye.